All right, today we're going to begin our unit on trigonometry. That's half of what this course is about, and there are going to be a lot of vocabulary in this first lesson that you may not be familiar with, so you need to take notes and pay attention to this vocabulary. So, in the past, you've used a protractor to help you to draw angles. But we're now going to superimpose those angles over the coordinate plane. And the reason we are doing this is because we're going to try and relate it to a circle. So in the first slide here, we have some general terminology. And an angle has two sides made by rays. The original side which it starts with along the x positive axis is called the initial side. That is the ray that your angle starts with. And then your angle can open up like this one does, or it can open down. And then the other side of your angle is called the terminal side because that's where it stops. And this arrow that's inside of the angle shows which way it opens from the initial side towards the terminal side, and that's why there's an arrow in there with this arc. You must put arrows on both ends of your angle as well. Now all of these angles have a vertex, and that vertex must be at the origin of the graph. And then to represent this angle, for example, this might be a 45-degree angle. We say theta is the letter that represents this angle. That's the standard for if you just want to name an angle, you name it theta. That is a letter from the Greek alphabet. And so in this class, you'll learn a lot of the new letters of the Greek alphabet to use to identify things. And theta identifies any angle that you'd like to talk about. Now, as we want to get more specific, we can talk about size of angles. Now, what you're used to talking about with size of angles is like 0 to 90 is acute, or 90 is a right angle, 90 to 180 is obtuse, 180 is 180 degrees is a straight angle. You may even talked about angles between 180 and 360. But the key here is with this lesson, that's not going to be the way I would like to identify the angles, because those are much smaller amounts of what the angle represents, and our problems, we represent them in a little bit more larger fashion because it's 360 degrees all the way around this graph. And so we want to have a little bit larger perspective than breaking it down to 0 to 90 or 90 to 180 and that type of perspective. So first we have what's called alpha angles. Alpha is the first letter of the Greek alphabet. Alpha angles are always positive, and they're from 0 to 360, so that makes it go around in a circle, a certain number of degrees for part of a circle. They always open counterclockwise, the opposite way from which the hand's on the clock, so these always open up from the x-axis on the positive side. Alright, so when you talk about an alpha angle, again, it's opening up. And so in this one, you have to label the x-axis and y-axis with how many degrees it takes to get through each quadrant to go all the way around to 360. Then you draw your angle and make sure you show this arc mark showing which way it opened from the x-axis over to the terminal side. And so this is what you do with alpha angles. And again, alpha is a Greek letter of the alphabet. And you may have seen it before as a fish look. Mine's more italicized here on the board, but that's kind of what we're drawing, is that fish look that a lot of people use for a religious symbol. That's the alpha symbol of the Greek alphabet. It's a lowercase letter. Then we have angles that open down. And angles that open down are called beta angles. And all negative angles from any number less than 0 is called a beta angle. You'll notice that earlier our alpha angles only go to 360. Well, beta angles don't stop at negative 360. They keep going forever. They open clockwise. In other words, they open down like the hands on a clock moving around. And you always label your numbers in the opposite direction so that negative 90 is down at the bottom instead of at the top where positive 90 is. And that's about the only big thing that you have to really remember, is that it goes around in a different direction, so you have to number it in a different direction for the negatives. Otherwise, it's pretty much the same thing as alpha. Now, you need to stop if you need to between these slides and copy this vocabulary. So if you need to go back and re-listen to anything, you can replay the video and stop it at any point and take notes, because that's what you should do when you're out. So this is called gamma. Gamma angles are angles that are above positive 360. They are not equal to 360 because that would make it alpha. It has to go past 360 to be a gamma angle. It's counterclockwise just like the positives. It opens up and they spiral, showing that you go more than 360, because around a circle is 360 degrees. So if you go around more than that, then you have a spiral effect. See, 420, if you take 360 away from it, is 60. And so I have spiraled a whole 360, and then this little piece right here, from the x-axis back up to the terminal side, that is the extra 60 that it took to make 420 go past 360. So you number it the same way you do an alpha angle, but you spiral it to make it go around more than one time. And we'll show you more in depth on that when we start drawing some on our own. So now, if you have not copied down any of this vocabulary, you might want to stop the video, go back to the beginning, and copy all this vocabulary down before you start taking examples. Vocabulary in this class is very important. So the directions say draw each angle, state the quadrant, the type of angle, and label all the axes. So that's a lot of information that will be giving you points for doing each piece. Let's go through very quickly an example of what are all these directions telling you to do. Well, I guess we need to learn where angles are on a coordinate plane. So in order to do that, I have for you a coordinate plane kind of divided up. This is in Canvas, and you can print one of these down for yourself. Yours won't have these lines on it, nor does it probably really have to have these lines on it. But I've kind of divided it up so we can look at it from certain regions. But you can print one of these down and take time to fill it out. So if you want to stop the video now and print you one of these so that you can fill it out as we're going over this, then do that now. And I'll pause here for just a second so that you can pause the video. So now, let's talk about how do you number what's called a unit circle. Now, 0 is always over here at the right side of the origin on the x-axis because that's your initial side of your problem. But you'll notice that some of these problems have a little more space between them. So we're going to divide this space between each of these lines that has the bigger space in half, so that it will be evenly spaced apart all the way around. Now, these lines go up by 15 degrees. So if I put those extra lines in, it makes it easier to add up and go by 15s. So from 0 to 15, this 15 line, we'll probably never use it for anything else other than to help us to get the pattern going. So if it goes up 15, it'll be 30, up 15 more is 45, up 15 more is 60, up 15 more is 75, up 15 more is 90. And so it's not difficult to keep adding 15 and go all the way around the unit circle. And so 105, 120, 135, 150, 165, 180, 195, 210, 225, 240, 255, 270, 285, 300, 315, 330, 345, 300. Oh, I wrote that in the wrong place. 360 degrees. And how I knew I wrote that in the wrong place is I see the degree mark now is under one of my lines. So you've got to be able to number all the way around this unit circle so you can see which of these lines represents the angle you're talking about. So for the angle that we were just discussing, we could have figured out where 45 went, but we might not have been able to figure out where 240 went. So that's why you want to learn this unit circle. You need to memorize in your mind the location of each angle, and not in order also. You need to be able to spur of the moment say, where does 300 go? Quadrant 4, just a little up from the y-axis. Alright, so we now know that 45 is in the middle, and that's what these blue lines are there to represent, that they're dividing things up in the middle of quadrants, or the middle of half the graph. So 45 is in quadrant 1 in the middle. So let's go back and look at our graphing. So now that I know that, let's number our graph. 0, well, we'll use a different color. 0 degrees and 360 is on the x-axis on the positive side. Then you go up to 90 at the top, 180 is on the negative axis for the x-axis, the negative part, and 270 is down at the bottom on the y-negatives. You always draw from the origin out on the x-axis a line. Well, mine's not very straight, but that's okay if yours is a little crooked also. But on the x-axis showing that's your initial side. And then I make a line in the middle of quadrant 1 to represent that's where my terminal side of 45 is. I make an arc mark showing it opens up. Since 45 is less than 360 and positive, that makes it an alpha angle, and I'm in quadrant 1. You have to do all of these different pieces. You have to have the angle with arrows on both ends, the arc mark in the middle showing which way it opened with the arrow, the alpha symbol, the quadrant, and the labeling on the axis to get those directions completely covered. Now in our second example, we want to do negative 90. And as I said before, we number in a different direction for negatives. Negatives start at the bottom with negative 90. Then negative 180 on the side over here on the left, negative 270 at the top, and 0 and negative 360 are all over there on the positive x-axis. For us to go negative 90, we have to go down to the bottom. So first we'll draw our terminal and our initial sides to make a 90-degree angle, and then we'll show an arc mark showing that it opens downward. Now any angle that opens on a negative is called a beta angle. And this one happens to not be on a quadrant at all. This is, excuse me, not x, y-axis. So sometimes they're not in a quadrant, but they're on an axis. And you need to state it that way, whatever axis it stops on. All right, let's look at another example. So this time we're looking at 585. So 585 is way past 360. So this will be a gamma angle. So we still start off our numbering the same in terms of labeling. Go up to top for positive 90, over to the left for positive 180, and 270 is at the bottom, and our 0 and 360 is where we start with our terminal side. Now we have to take 360 away to see how much over 360, because this is going to be spiraling, and that's 225. So we go to our unit circle and see where is 225, and 225 is in the middle of quadrant 3. So we'll come back and we'll draw a line down. Whoop. Let me put that back where it goes. Draw a line down through the middle of quadrant 3. So this is a gamma angle. 585 is a gamma angle. It's in quadrant 3. So I start by opening it up because I want to go around, all the way around one time for 360 degrees. Then you're going to do 225 back to the terminal side and put your arrow on the end of your arc. So that's what gamma angles do. They spiral around to show you've gone more than 360. Alright, so here we have another angle that is negative. So let's label our axes with the negatives. Now 0 doesn't have a negative on it, but the 360 does. And so when I want to figure out where 210 is, it first helps to know where positive 210 is. Positive 210 is in quadrant 3. So that would mean that I had to start over on the x-axis and come around to this angle in quadrant 3. So if I do that same thing, I want to look at where would it be if I open it in a negative direction. And the best thing I can explain to you is to look where it is in a positive direction and flip it across the x-axis, and that's where it will be for a negative angle of 210. Negative 210 and positive 150 are both in the same place. So I'm going to open it up from the x-axis to about 30 degrees above it. So we're going to put this angle about 30 degrees above the x-axis in quadrant 2, because that's where the negative angle would be that would open around 210 degrees. So this is a beta angle of negative 210 in quadrant 2. So with degrees, you can see there's a big difference in what you can do here, depending on if it's positive or negative, on which way you open it. Alright, we're going to look at one more. I wanted to look at a negative angle that was more than 360 so you can see how that works compared to an angle that we've already done, one gamma angle. So I'm not probably going to do this 620 over here. I'm just going to focus on this 500 because I want you to see the difference between it being positive 500 and negative 500. So first we have to number our axes by negatives. Then we have to add 360 to, instead of subtracting 360 like we did with gamma angles, because it's already a negative number and that'll make it subtract. And that comes out to be 140 degrees. Now 140 is not on our unit circle, but 150 is, so 140 would just be a little bit above that. And so negative 140 would be down here between 210 and 225. And so that'll be in quadrant 3. So always think about where it'll be as a positive and then reflect it to figure out where it'll be for a negative. Well, it doesn't want to write. So now this is a negative angle. So we're going to spiral around one time because we took 360 and added it, and come back to 140. Now I shortened that just a little bit. I should have not spiraled that quite so close, but at least I can see it's apart. So this is a beta angle of negative 500 because anything that's negative is always beta, and it falls in quadrant 3 because 140 normally would fall in quadrant 1. So negative 140, which is what you get from negative 500 and 360 being put together, negative 140 would make it fall in quadrant 2 if it was positive, so negative makes it quadrant 3. So on Monday we had this lesson, and so now in Canvas there is an assignment for homework on 5.1 where the 1 through 6 is all in degrees, and therefore you can work these questions based on drawing the pictures like I have shown you here.